But with that description alone, right, maybe the alien would envision a cat to be something like this, right? Well, is this what a cat looks like or is all about? And of course, it's not, right? Yes, this is a kind of like a small nose, kind of furry animal, but it doesn't resemble a cat at all, right? So you could also try a different approach altogether by using a series of descriptors, you know, words that are characteristic to a cat. You know, things like it's agile, it's a predator, it's wild, it's vulnerable, right? Clever, patient, dynamic. But even some of these things, they kind of feel almost mutually exclusive, right? They don't even seem to align that well. So if you think about a cat being vulnerable and patient, but also being dynamic and energetic, right? They're almost like they seem like they're kind of like a different animal altogether. And then, of course, using descriptors only makes sense if the alien himself or herself knows how to combine these different letters in a meaningful way, right? They can understand the specific symbols that you're using, letter P, R, E, D, etc. And these are, of course, the building blocks of our alphabet, you know, our 26 different building blocks. And this is, again, assuming that the alien would have to not just understand what each of these symbols represents, but also the various rules, the guidelines on how to combine them to create meaning, right? To create language, to create something that you can decode as information. And this is, of course, if the alien would happen to land in Paris, right? Or some other city that actually uses those 26 characters. If the alien happened to land in Casablanca, in Morocco, it would be a whole different system altogether, you know, of symbols, but also of a whole different set of rules to combine those symbols in order to create meaning, right? And these are just two very different systems that the alien would have to sort of understand, depending on the location that he or she would land. Of course, depending on the location, it would all be a whole different system. Estimated today, we have around 370 different types of alphabets, right? This is actually a chart from 1689 depicting all known alphabets by Edward Bernard, right? So it's quite a complex process on its own. And this is, of course, not even accounting for, you know, old alphabets that are no longer in existence today. This is actually some of the oldest, what is known as a proto alphabet. You know, before the alphabet became a thing, you know, our first alphabet in ancient Sumer, we had human beings had these little tokens. These are clay tokens that you could use to represent information, sometimes quantities as well. And they would exchange as you would normally do for doing commercial transactions, right? And then over time, some of these clay tokens emerged into what's known today as the first known human alphabet, which is the Sumerian cuneiform. And you can even see here how some of these early pictorial representations slowly evolve into that sort of cuneiform alphabet on the right hand side of your screen. So this is clearly too hard for aliens to just even grasp the whole idea of a cat by using language, right? By using written language and alphabets. So the alien tries a different approach altogether. The alien now asks, can you actually draw me a cat? Now, do you think that's going to be more or less options when it comes to drawing a cat? It's probably going to be as many, right? If not even more. Why? Because there's infinite ways for you to draw a cat, and there's infinite styles of drawing that are very personal to each one of us as well, right? So look at just the diversity of drawing styles from one single person. These are all drawings by Picasso himself. And here you have only drawings of a bull, which of course, as we all know, Picasso was somehow obsessed about. And what I love here is that on the bottom left, you have a very sort of pictorial kind of real life representation of a bull. You know, there's a lot of texture, there's a lot of weight to the animal. But then on the top, on the middle right hand side of that beige drawing, you have arguably sort of the most abstract representation of a bull, right? It kind of plays with like the limits of human imagination, right? Or human perception, in the sense that it's using one single thin line, and you can still look at that really abstracted drawing and kind of see a bull, but it's still very different from the one on the bottom left of the screen, right? Completely different, I would even say. But it still shows like the infinite ways that you can use to draw a bull. So imagine this is just one single person. I imagine what thousands and thousands of people around the world and the different styles that they might have to actually draw something. So you don't have to imagine, because this is really an exercise that Google did a few years back in this quick draw challenge. And here people are asked to draw anything you can think of, you know, from a calculator to a birthday cake, to an apple, to a book. Just trying to understand how different are the various human ways of interpreting a given object. And this whole process is done and it's really feeding this AI kind of kids game, where as soon as you start writing something on the screen, the system completely starts to guess, you know, like, here we go. I see moon, I see circle, potato, it's a donut, right? There you go. And then as soon as you start drawing something, the system is continuously guessing what it is that you're actually drawing based on thousands and thousands of drawings from people around the world. Now you have to draw a crocodile. So now the system is guessing. I see a planet, I see a moon, a flamingo, pliers, a dog. Then finally I see dragon, right? Pretty cool. So because we're talking about cat, this is actually 103,000 drawings of a cat, right? Made by people all across the internet. Immediately when you look at all these drawings, you see there's some different types of patterns, right? There's, you know, the sort of the familiar circle with two triangles on the top representing the ears. This is arguably the most abstract shape of a cat, similar to Picasso's drawing of a bull. Then you have a little bit more detail on the face of the cat. And then the third is a whole different approach, right? It completely ignores the specific details of the face, and it's really more about the body, right? The silhouette of a cat. So what about camouflage, right? Imagine that camouflage is not as easy as cat, right? So when you get to camouflage, then you start seeing a little bit more divergence, right? People are starting to sort of draw many different things, and it's kind of hard to pinpoint what is exactly is sort of the right direction or the one that kind of resonates, you know, from garments to kind of like the scribbly lines. And that's because, you know, when you go to more ambiguous terms, it's the ultimate Pictionary challenge, right? You know, things like generosity, elegance, honor, hope, loyalty, right? Talent, weakness, wisdom. How would you actually visually represent any of these terms in a meaningful way that could be easily understood by others, right? It's really, really hard. It's really challenging. Or apparently, as I came to find out, BlackBerry is also very challenging for many people. And it's really funny because in the system, right, BlackBerry, as you can see, it's a little bit all over the place, right? Primarily because, of course, there's BlackBerry, the technology, right? The handheld device, like the mobile phone, BlackBerry. But there's also, of course, BlackBerry, the fruit. And what I love about this is that you can see how the details when you look at a BlackBerry, it's actually so intricate and detailed that it's actually hard to really see the whole thing. So some people just give up, just like do a little bit of a scribble here and there to kind of finalize it. So this is a challenge I normally ask people, like drawing on quantities, right? In how many ways do you think it's possible for us to visualize this, visually represent these two quantities, 7 and 14, right? So normally when you do this challenge, when I'm actually looking at the audience, and I give them maybe like 5 minutes or so, you might have people that create maybe 15 ways, 20 ways, but it is really infinite if you think about it. When you really have, if you had all the time in the world, there's almost infinite ways of visualizing any two quantities, right? In this case, 7 or 14. So you could look at 7 and 14. 7 and 14, by the way, numbers which are themselves already a visualization of a quantity, right? Because you could have used Roman numerals, you could have used Sumerian numbers, or any other sort of alphabet that we use today. You can use, little boxes to represent quantities, the length of bars, the size of the shape, right, of a circle, of a box, of a rectangle, of a square, number of flags on the screen. You can even map numbers and quantities to specific phases of the moon, right? To specific hours, time of the day, to specific color variations, right? So all of that can be mapped through numbers in a specific quantity. And you could go even broader, like the wavelengths, the arc thickness, etc., etc. This is actually part of an article that a friend of mine, Santiago Ortiz, did called The 45 Ways to Communicate Two Quantities. And of course, he identified 45 ways, but there's many, many more, right? It's really only almost infinite. And so in the same way that we had almost infinite ways of combining these building blocks, right? The alphabet to create language, to create anything from poetry to a description of a video game, right? We also have a set of building blocks when it comes to information design and data visualization. And these building blocks are not letters themselves. They are shapes. There are different sizes. There's color, right? Multiple traits that allow us to combine these shapes in multiple ways and create meaning and convey information. So Bertin really says it all when he writes that graphics is a system of science which anyone can learn to use and which leads to better understanding. So in other words, data visualization is really a language. So now let's look a little bit about the grammar of this language, the grammar of data visualization. Even though today, a lot of us know the sentence, the whole is more than the sum of its parts. It was really back in the 4th century BC by the work of Aristotle himself that this sentence really became ingrained in our head, right? And, of course, Aristotle was the first one to mention it. But over the centuries, people kind of knew this type of idea, right? That the whole is more than the sum of its parts. But in the early 20th century, the Berlin School of Experimental Psychology was really doing a lot of really interesting work in this space. And this really became ingrained in society in general, in a body of work that later became known as Gestalt psychology. And Gestalt basically tells us that the operational principle of the brain is ultimately holistic, or in other words, it is irreducible. This means that the recognition of shapes and forms in our brain is not just, we don't see a collection of elements like dots and lines. We actually see them as a fully identifiable pattern, which is called the Gestalt effect, right? And this is why, for the most part, most humans will look at this image and see a Dalmatian dog in the foreground. But still, many machines today would not be able to clearly read that or understand such a concept. So we can understand and we can see the Gestalt effect in various ways that are absolutely critical to how we design, right? One of them is the law of similarity. And this tells us that elements that are similar are perceived to be more related than elements that they are dissimilar, okay? So as soon as you see these three columns on the screen, yes, you do see that they are a block, right? A column, but immediately you perceive, you notice the differences between the various elements, right? You have small and large circles, you have blue and gray circles, and then you have circles and triangles. That's immediately graspable. Color, for example, and many others can be highly effective when it comes to visual design, user experience, and data visualization. This is an example of using color where each color is actually associated to a category. And every time you see a card with a given color, you associate it with that category. Here we can see that idea of similarity applied to data visualization. Of course, that you have a legend on the bottom, and color is associated with a category. That's because, again, every time you see that color, you associate it as being similar, right? As being part of the same kind. And this is, what happens in this beautiful visualization of a chess game. And even though you don't really know or even read all the individual moves and where they took place, at a glance, you identify those two colors and you associate, yellow and green by being two separate colors, therefore two separate players in a game. This is yet another approach. This one is all about size, right? We talked about color, we talked about size. On the left side, notice that they don't use any type of color whatsoever. It's all about size. This is a visualization of GDP. And immediately you can see some big, large countries like the United States, China, Japan, and Russia, or maybe just even like the United States and China, the two biggest players. Then you have at a mid-sized level, you have Japan, Russia, India, France, Canada. And then you have the rest, right? The smaller, much smaller countries in terms of GDP. And then again, we are here using the same exact shape with the only changes in size. And that size really helps convey the difference between all the elements. Apart from the law of similarity is also the law of proximity. And the law of proximity is really the ultimate law. And it tells us that elements that are close together are perceived to be more related than elements that are further apart, right? So immediately you do see the difference between, of course, there's a triangle and there's like a bunch of circles, but your brain detects 5 individual groups on the screen. Why? Because we associate proximity to being related. So you just create 5 separate groups of 3 circles and 1 triangle each. And the law of proximity is absolutely paramount in user experience design, for example. Here you have a very quick sort of prototype of a mobile app. But notice how by having the plus and the minus button side by side, immediately you associate them as being related. So you're probably controlling the same experience. Now imagine that I was to put the plus button on maybe the top right of that screen and maybe smaller, right? Now you wouldn't really have that association whatsoever. They would seem completely separate, completely disparate. And this happens every day when it comes to our own frustrations with software. This is a tool that a lot of big companies use, which is called Concur. And I remember using this tool to submit expense reports when I was working at Google. And I was just, typing all this information, writing everything, the report name, the date, comments. But then when everything was done, I didn't know what else to do. I didn't know, okay, what am I supposed to do next? What is the next step? And of course, I completely missed the next button. That's actually at the very bottom right of the screen. And I completely missed that. So again, this is the law of proximity done wrong. And the law of proximity also happens in real life. I love showing this because it really highlights how important this principle of Gestalt really is. So instead of no smoking, safety first, what you can actually read straight away is no safety, smoking first, which is really funny. It's really hilarious like that. This is actually still showing on a boat today. And if you notice, they even tried to change this error, right? They painted no smoking red and safety first is black. They could even have used different fonts, different typefaces. It wouldn't matter. You would still read those things as you are reading them now. Why? Because the law of proximity supersedes any other law. It's the ultimate design law. And we can see this in data visualization as well, right? So a scatter plot, for example, is one of the charts that takes a great advantage of this law of proximity, where it's not so much the shape or even the color, it's about the patterns that it makes, right? It's about that sense of like the clustering, right? The clustering, the grouping, and identifying those groupings in meaningful ways within a screen, right? The hotspots, the hot regions. And that all happens through the law of proximity. And so we saw a little bit how the law was really trying to, some of the laws of Gestalt were really attempting to sort of explain how the human mind kind of works and how we interpret graphical input. So in 1973, Donis Dundes made a great work in what's called a primary visual literacy. And here she really deconstructed the many qualities of visual representation, like balance, symmetry, contrast, into small building blocks, which she called the skeletal visual force. And she observed and researched various types of pieces, from painting to graphic design, etc. And she understood and she wrote some of these building blocks, what these building blocks actually were. She wrote that it was primarily the dot, the line, shape, direction, color, texture, movement. And when you combine this in interesting ways, and of course, artists have known this for centuries, you can really convey, things that like unity, harmony, consistency, diffusion, singularity, distortion, fragmentation, right? There's almost infinite feelings, emotions, or concepts that we can evoke and communicate just by using those simple techniques. Then Jacques Bertin went a step further, right? He actually included some of those building blocks that Dundes identified and say that these are really the 7 main categories of visual variables. This is the alphabet of data visualization, right? The alphabet of data visualization as a language. Things like position, the shape, the color, texture. This is just another way of looking at the visual encoding, right, of all of these. And what's great about many of these variables is that they all fall into Gestalt. The position is all about the law of proximity. And then the various differences of shape, size, color, orientation fall into the law of similarity. And then William Cleveland and Robert McGill in 1984 went even further than Bertin. And they basically tried to rank the various variables that Jacques Bertin had identified in terms of accuracy, right? So they realized that position on common scales, like position, is still the most accurate. The ones we can depict the differences more closely. Length is still very strong, comes up at number 3, but it's not as accurate as position. That's why scatter plots still to this day are so favored by the scientific community because of its precision. Then you have things like area and volume, and then you start losing a little bit of the accuracy there, because when you have volume, for example, then you are dealing with things like perspective, and that can really be not very clear to the end user. And then finally, you have color, right? I'm not sure how many of you know why color is the last one of the list when it comes to accuracy, but it is the last one because color, as many of us know, can suffer from severe accessibility issues, because there's many people with different types of color blindness, right? Which afflicts mostly males, predominantly males. Deuteranopia is actually a disease that's affecting roughly 10% of all US males. And for a person with that type of symptom, an easy heat map, like you see in the table on the left, where green and yellow and red, the normal sort of heat map that you might see somewhere else. For a person with that condition, they wouldn't be able to see that at all. They would, the dark green would look exactly like the dark red. It would be almost impossible to tell the difference. And this is serious, right? Because again, we use color often in data visualization, but we forget how different people might be reading it, in a very distinct way. Now, I'm going to jump, just for sake of time, in terms of understanding the data, to this final piece, and hopefully I'm going to have another chance to talk to many of you on some of these points. But the last piece that I want to really talk about is not so much the grammar of data visualization, on understanding the data visualization as a language, which we talked about before, but it's also understanding that data visualization is inherently diverse. There's a great diversity when it comes to data visualization. So if you recall, just all the different ways that you could, depict or represent a cat, right, the animal, there's of course also endless ways of depicting a city like New York, right? When you look at this image, imagine how many different ways you could visualize it, how many visual metaphors you could come up with. And every time I think about this, I also, of course, think about this quote by Alfred Korzybski, that basically says that a map is not the territory. And every time I think about that quote, I also think about this beautiful painting by this arguably the most famous Japanese painting of all time, right? Called The Great Wave of Kanagawa. And what many people don't know is what is the main theme of this painting. Some might think it's the tsunami, right? This massive wave about to crash. Others that it might be the fisherman's struggle with the sea. You can see a few boats there as they struggle to keep afloat. But the main subject here of this painting is actually Mount Fuji, the highest mountain in Japan, which you can see at the very foreground of the painting. And in fact, this painting is part of a collection of paintings called the 36 Views of Mount Fuji, where you see Mount Fuji seen from the city, from the mountains, from the plains, from every possible angle. It's almost if you had a 360-degree angle or degree camera, and you were just shooting Mount Fuji from every possible viewpoint, right? So this is, if you remember anything from the talk today, think about your data set, your database, whatever the subject you want to represent as your Mount Fuji, right? There's infinite ways of depicting it. So this is an example. Often you get an article on the media saying, hey, this is the map of the internet. This is how the internet looks like. And this is, of course, one interesting map. This was actually called the Internet Mapping Project in the last century, 1998. But of course, when you look at this, you have to take it with a grain of salt. It's not the map of the internet. It's one possible map of the internet, because there's endless ways you can look at the internet, of course. this is my sort of recreation of the 36 views of the internet, where you can look at this system from the infrastructure, right? The backbone of the internet, the physical infrastructure of cables that make this system. You can look at maybe some of the conversations that happen there, the connections between machines, between servers, IP addresses. There's endless ways of visualizing the system. Or like this one, which was really a competition of data visualization a few years back, where users were given the same data set. And the data set was really including all recorded meteorites that hit planet Earth since 2500 BC. And it was exactly the same data set, but that same data set caused this variety and diversity of approaches, right? Once again, seeing how there's not one single possible map or interpretation. There's many possible maps. And likely, if you really want to have an understanding of a phenomena, you need more than one visualization, because one will never be enough. You need multiple angles to understand this problem from the various sides, the various facets. So, what is the right map to show? Again, there's probably not a single one. There's maybe multiple maps, right? So the things that you have to consider are, the data types you have, the context of the data, the specific task that users want to perform, the question you're trying to answer, or the specific message you want to deliver. And with this, I end up my presentation. This was a bit of a short one, 30 minutes, but hopefully at some point in the future, you will have a chance to hear me speak more in detail about other related subjects on this and other topics. So thank you so much for having me. It was a pleasure. And I hope you are enjoying this conference.